Alright, welcome to lesson 10-10. This is the last lesson of chapter 10. I know, very sad. Today's lesson is about scale factors and solids. This is what our fellow geometry students have been working with recently, so pre-algebra, you're catching up to geometry real quick here. It's kind of nice that you guys are in the same class right now. So if you ever need help, don't hesitate to ask your geometry friends. Alright, enough said. You're going to need a ruler, pencil, colorful pens, and paper for today's lesson. When you have those materials ready, hit play. Alright, so to find the dimensions of similar solids is what you're going to be working with. That's your goal. Find dimensions of similar solids. So first we're going to talk about what a similar solid is. So a similar solid, say you have two rectangular prisms. They aren't the same size, okay? First off, just know they aren't going to be the exact same. But they are what we use the symbol this for similar. Okay, that's what similar is. So these two figures could be similar if they're the same shape, but not the same size. They must be proportional, though. The technical definition you can use, one way to remember it, is called scale. So similar, here I'll write out what it means. Scale is similar shapes have congruent angles. Congruent angles and side ratios that are the same, or that are equal. Okay, that's scale. So if a similar shape, you should already know this, right? This should be familiar from chapter 6, but we'll go rebrief it really quick. Say you have two rectangles here. So if they're rectangles, they all have right angles in their corner. Okay, if it has all right angles, that means, in terms of scale, that we have congruent angles. That's a good go, right? Because we all have right angles. Side ratios that are equal. Oops, forgot the E on scale. Ratios that are equal. Let's look at our side ratios. If I gave you a side of 8 here and a side of 4 here, side of 2, side of 4. Okay, the ratio between the sides of this shape is 8 to 4. That equals 2 over 1, so that's just 2. The ratio here is 4 over 2. Remember, we're going to go long to short. So I should change color for that. Long to short, and same thing on the side I went I did the same thing on that side. I did long to short. Long on top. Long on top. Okay, it has to be the same, otherwise you're not going to get, you have to go long to short, or short to tall, short to long, short to long. It needs to be whatever's on top for one side needs to be on top for the other when you put it in your, as a ratio. The ratio is just a comparison of numbers. Okay, so 4 over 2 equals 2 as well. So 2 equals 2, so our side ratios are the same. Side ratios equal. So scale works, we know they are similar, so we can add this symbol. This shape is similar to this shape. They're not the same size, right? But they are the same shape. So it's the same is true of three-dimensional figures. You can have similar three-dimensional figures. That can be similar to this bigger square box. If they have similar side ratios, okay, they have similar side ratios. Let's check. We know it's a square box. It's going to be all right angles. So we know in this case congruent angles, right? Because they're congruent here. Let's check if our side ratios are equal. 4 over 6. We're going to go short to long. Here let's go short to long as well. 2 to 3. 4 over 6 equals 2 over 3. 2 over 3 equals 2 over 3? Yeah, so we have ratios that are equal, so we know they are similar. Okay? That's what a similar solid is. Right here. Similar solid. Solid shapes, three-dimensional figures that are similar. So we can construct similar solids by multiplying the lengths of all the dimensions by the same number. This is called the scale factor. It's a ratio of the length in one solid to the corresponding length in a similar solid. Alright, we're going to do an example showing what this scale factor is, and then we're going to talk about using the scale factor. So we're just looking at a ratio. Remember, it's a number. A ratio is just a number over a number of the length in one solid to the corresponding length in a similar solid. Okay, so we need to know that the shape is similar. We need to see the similar symbol. And we need to know it's in the corresponding part, right? So if you have in this solid here, if we're talking about the height, we need to talk in the similar shape about the height as well. Okay, so we're looking at the corresponding sides. We're not doing x to y, or x in this side to y in this side. We're doing x to x. X to x. Ratio, it's x over x or x to x. Those would be comparing the corresponding sides. Okay, right, these sides correspond with each other. Okay, so let's do an example of this, so we can see how scale factor comes into play. So if we're going to find the dimensions of a similar solid, remember that's our goal for today. To find the dimensions of a similar solid, we have, let's start out by drawing, we have a pyramid. Oops, with an extra funny line on it. Okay, we have a pyramid, 6 centimeters here, slant height of 5 centimeters. We have another pyramid, it's larger. Oops. Oops, oops, oops. Another pyramid that's larger. Slant height here of 12 centimeters. and a base of x. We don't know what the base is. Okay, I'm going to give you the information that these are similar. Okay, if I draw the symbol similar there, you can use that information. Or if like the problem in the word say they are similar, then you're gonna know you can use the scale factor to find an unknown side. Okay? So if we know that they are similar, right, if you are given something that they are similar, then you can use the scale factor to find the unknown side. So we can figure out what x is by using the scale factor. So let's go ahead and do that. Oops. Okay, so if we have, let's set up a scale factor. So our scale factor, remember it's going to be a ratio. If we look back at our definition, it's a ratio. It's a number over a number in the corresponding position. Remember, corresponding position. So here we have 6 to x are in the same position, but we don't know what x is. We need to look at our given information, something that we have both of. So we have both of our slant heights, right? So we can compare and set up a scale factor for the slant heights. So we can say, let's go small to large for our triangles. So 5 over 12 is our scale factor. That can't be simplified at all. That's as simple as it's going to get, so let's leave it like that. 5 over 12. Okay, so we can find then the length of the unknown side by setting up a proportion. You know that the scale factor between the slant height, the 5 and 12, is going to be the same as the scale factor between the 6 and x, because they are similar. So we can say, so first you find your scale factor, second, set up a proportion. And a proportion, if you'll recall, is x over x equals, oh, sorry, I guess I shouldn't do x over x. Let's do a number over a number equals number over number. Okay, proportion has the equal sign in the middle. It is an equation. So we can use this equation. We can say 5 over 12 equals, remember we started with our small side, so we need to start with our small side here. 6 over our corresponding part is x. Now you can, with a proportion, you can cross multiply. Okay, so 6 and 12, 5 and x. So we will set up, don't multiply in your head, write it out. 5 times x equals 12 times 6. Don't ever just do it in your head, write it out first, then you can do the multiplication. But show how you went from, by drawing the arrows, right, and then writing out what you're multiplying by each other, you're showing your work. You're showing that, oh, I cross-multiplied. Otherwise, I won't know where you're getting your numbers from. Okay, so 5x equals 12 times 6 is 72. I'm going to simplify to solve for x, so divide by 5. So x equals 72 over 5, which is 14.4. So we have 14.4 as our x. That's our unknown side length, and that's centimeters. Okay? So we were able to use the scale factor, well, the relationship we knew between the two similar pyramids in order to find the unknown length. Alright, I'm going to have you do an example with this. This time, though, you're going to have 2 cylinders. Oh, my cylinders don't match up. 2 cylinders. The small cylinder here, we have a diameter of 4 meters, height of h. We have another cylinder, the height of, height of 11 meters, and a diameter of 5 meters. Alright, go ahead, find the unknown length using scale factor. Pause the video, try to solve this on your own. When you're ready to check your answer, hit and play. Alright, so you should have found that h, your unknown height here, is 8.8 meters. Okay, you would have found this by 1, setting up a scale factor. I think I verbally told you that they're similar. I didn't actually write it down. But so these two shapes are similar, so you're going to set up a scale factor between them. So look at the corresponding sides. Well, we're given diameters of each, so we can go, let's go small to large. 4 to 5. It's as simple as it gets. Step 2, we're going to find the unknown. So we're going to set up a proportion. So we're going to say 4 to 5 equals, remember, go small to large, our unknown height over 11. We're going to cross multiply, so show it in your steps. So draw your arrows. So 4 times 11, and then 5 equals 5 times h. So 4 times 11 is 44, equals 5h, all divided by 5. So h equals 44 over 5. So h equals our 8.8. And then we know it's meters. We were given all our units are in meters. Alright. You can also use scale factor to find surface area and to find volume. So we still need to be working with similar shapes, similar solids, and finding a scale factor, and then we can go ahead and then figure out what a surface area and an unknown surface area or an unknown volume is. So if you're talking about the ratio of similar solids is, as we just did, A over B, right? If we had, say, A for the height there, and then in this shape you had a height of B, so it'd be A over B would be like a scale factor. The ratio of surface area, it's not just A over B, but it's A squared over B squared. Okay, you're talking about area. Okay, predict, what do you think the ratio of volumes is going to be? Think about it. What do you think the ratio of volumes is going to be? Write it down. Alright, if the solids is just a over b, surface area is a squared over b squared. Volume, area is always in squared. Volume, your units are always cubed, so it's going to be a cubed over b cubed. Okay, this is for your scale factor. So this is what we're going to be using, this a squared over b squared to find the if you're finding an unknown surface area, or you're going to use a cubed over b cubed if you're finding an unknown volume. Let's go ahead and practice with that. So example 2, we have a cylinder with a 6-inch diameter, and we have a smaller cylinder with a 3-inch diameter. Alright, I'm also going to tell you that the surface area of the large cylinder is 90 inches squared. The large and small cylinders are similar. Cylinders are similar. And the volume of the large cylinder is 157 inches cubed. Okay, so I want you to find the surface area and the volume of the creamer. It's our target question. Surface area and the volume. Okay, so we can do this by saying we know that the scale factor of solids is just a over b, so our scale factor in this case between our large and our small cylinders is going to be, let's go to large to small, 6 over 3. So that is 2 over 1. So then the ratio, if we wanted to set this up, this is for solids, right? But we want to find a surface area and a volume. Let's start with surface area. So the surface area proportion. We can't quite set up our surface area proportion quite yet because we don't know what our surface area scale factor is. This is was 2 over 1 is a solid scale factor, but a surface area scale factor, if you look back here, is the a squared over b squared. So it would be 2 squared over 1 squared for our surface area scale factor. So that's 4 over 1. So now we can set up our surface area proportion. So 4 over 1 is 2. Well, our large surface area is 90. We're doing large to small, so 90 over x. So now we can go ahead and cross multiply and solve for our unknown surface area, x. So that would be 4 times x equals 90 times 1. So x equals, if you divide that all by 4, right, to get the x alone, 4x equals 90. I'll divide by 4. So x equals 22.5. And this is inches squared because we're talking about the surface area. So if our surface area for a small cylinder is 22.5 inches squared. Let's go ahead and find the volume. So step 3, the volume of the small cylinder. Well, we don't know what our volume scale factor is. Remember, our initial scale factor is 6 over 3 or 2 over 1. 2 over 1 equals A over B. Our A cubed over B cubed is the ratio of the volume. So we need to make this A cubed over B cubed to get a new scale factor in order to find the volume. So that will be 2 cubed over 1 cubed. That equals 8 over 1. Okay, so let's go. We're still going large to small. So we have 8 over 1 equals, and our volume of our large cylinder is 157. So 157 over x. We want to find the volume of the smaller cylinder. So let's cross multiply. So 8x equals 1 times 57, or 157, all divided by 8. So x equals 157 over 8. That's a 19.625. So we can say that's about 20 inches. And this is going to be cubed because we're talking about volume. Volume is always in cubic units. So inches cubed. So let's go back here. So our volume equals 20 inches cubed. Alright, so we found our volume and our surface area of our smaller cylinder by using the scale factor we started with the scale factor of a solid. We then were able to change that into a scale factor of a surface area by squaring both numbers, right? And we were able to do the same thing and set up a proportion and solve for the unknown surface area. We were able to do the same thing for the volume. Take our initial scale factor and say, okay, we can cube that in order to get the volume scale factor. We found our volume scale factor, we set up a proportion, and then we solved for our unknown volume. Okay, I'm going to have you do an example with that. Okay, so this is example 2b. Okay, so you have a box with a surface area of 54 inches squared and a volume of 27 inches cubed. The edges of the box are 1/3 the length of the edges of a larger box. Find the surface area and volume of the larger box. Alright, hit pause, go ahead and solve for the surface area and volume of the larger box, and hit play when you're ready to check your answers. Alright, so you should have gotten, your answer should have been that the volume equals 729 inches cubed, and your surface area equals 486 inches squared. I'm going to go ahead and solve this, making sure you have all your right work. Okay, so we start with, they give us a box, right? We have one box. and it is similar to a larger box. Start it with one box. We have a larger box. Oops. Oops. Nope, it doesn't want to let me draw there. Okay, we have our larger box. And the ratio of the sides, they tell us right off the bat, so really handy information. Tell us that the edges of the small box are 1/3 the length of the edges of the larger box. Okay, so you have a small box to a large box. They give you a scale factor, small to large, of 1 to 3, or 1/3. So we can go ahead and we can find first the surface area of the large box by thinking first, okay, what's the scale factor of the surface area? Well, surface area, remember, is going to have an a squared to b squared surface area. So we need to square our 1/3. So 1 squared over 3 squared is 1/9. So we can set up a proportion and say 1/9 equals, let's look back at our problem, equals, and we want to know our surface area of the small box is 54 inches. So we'll plug in small to large, so 54 over our unknown large surface area. So we're going to cross multiply. So 1 times x, so that's 1x, equals 9 times 54. So x equals 486. And that's inches squared, because remember, look back at our initial problem is in terms of inches. And area is always squared. So surface area of the large box is 486 inches squared. Okay, so then step 2, the volume of the large box. You find that by saying, okay, our scale factor of 1 to 3. We need to cube that in order to make it in terms of volume scale factor instead of just a scale factor. So 1 cubed over 3 cubed, that is 1/27. So the volume, getting back at our problem, we were given a volume of 27 inches cubed for our small box. So we're going to set up our proportion. 1/27 equals 27 over x. Let's cross multiply. Solve for x. 1x equals 27 times 27. X equals 729 inches cubed. All right. So that's it for today's lesson. So we're using that scale factor, whether or not things are similar, in order to find the dimensions of an unknown side or to find surface area and volume of unknown sides. So every time you're just finding the scale factor, so the major point of this lesson, your scale factor is that ratio, right, number over number, of the corresponding sides, or a corresponding length. So x to your similar shape, x to x, or you're going y to y, z to z, right? You're looking at the similar sides. It's a circle, look at your diameter, look at your radius. You're looking at the corresponding side lengths and you're setting up a ratio. And then you're using that and you're setting up a proportion, right? Equals something, a number over an unknown, or an unknown over a number. Okay, so you're going to do some practice in class today. So your in-class practice, you're on page 554 in your textbook. You're going to do numbers 1 through 3 and 5 to 9. Now that seems like a lot of problems, but this was a lot of steps, and I believe that the repetition is going to help with this understanding of these concepts. We had a lot of tricky concepts in today's lesson. Okay, your homework is going to be your 10-10 practice book page in your workbook. Alright, go ahead and get started on your in-class assignment.